Hi, in this video we are going to implement the breadth-first search graph traversing algorithm, so let's get started. I'm going to create a distinct class for the vertices or the nodes in our graph we want to traverse. And for example, I'm going to store integers. Maybe I should use this T generic type, but just for demonstration purposes, it's going to be the integer data. We have to store a reference whether this given vertex has been visited or not. And of course, we have to reference this to the neighbors. So we store a list of vertices, the neighbor list. I'm going to import the java.util list. In the vertex constructor, I'm going to set it's going to get an integer data. So this data is equal to data. And this neighbor list, I'm going to instantiate it in order to avoid null pointer exceptions. And of course, it's going to be an array list. Then I'm going to have a method public void add neighbor with a vertex. So this neighbor list add, we just add with the help of this method, we can add neighbors to this given vertex. And I'm going to generate the getters and setters with the help of Eclipse IDE for the data, for getting the neighbor list and setting the visited boolean variable. Okay, so that's all about the vertex. Then I'm going to have the algorithm itself. I'm going to call it maybe breadth-first search. Okay, breadth-first search. I think I spelled it correctly. Breadth-first search. Okay. And here I'm going to have a single method, the public void breadth-first search. We have to specify a starting vertex. I'm going to call it the root. And I'm going to create a queue, a simple queue interface. Of course, I'm going to store vertices, so it is going to be the queue. And because of the linked list data structure implements the queue interface, that's why I can use something like this, that the queue is the interface and I instantiate it as a linked list. Then I'm going to set the root.setVisited because we have visited it, so I set it to true. And of course, I'm add it to the queue. And if you may recall that we have to use queue data structure whenever we want to implement the breadth-first search, we will see that with the help of depth-first search, not breadth-first search, but the other graph traversal algorithm, we should use stacks instead, or we could implement it recursively. But as far as breadth-first search is concerned, we have to use a queue data structure. So while the queue is not empty, we just keep popping vertex, the actual vertex is equal to the queue that we remove the item from the queue. We just print it out to the console that the actual vertex plus some spacing. I'm not going to use println, but print instead. Then I'm going to iterate through the neighbors of this actual vertex. So the actual vertex that get neighbors list. And if this vertex is not visited, sorry, that's why I have to use the exclamation mark, then we set it to visited, to true, and I can add it to the queue. Add this V to the queue. So that's all about, and that's why I think it's very common for algorithms that the the fundamental basic of the algorithm is very easy. So that's all about breadth-first search. We create a queue data structure. We could use a linked list because the linked list data structure implements the queue interface. And we visited, of course, the route we specify here, and we have to run our algorithm as far as the queue is not empty. We just keep popping an actual vertex, visit all of its neighbors, and add it to the queue. So this while is going to run until the queue is not empty. So let's test our algorithm whether it's working or not. I'm going to create breadth-first search equal to new breadth-first search. I'm going to create vertices. Vertex 1 is equal to new vertex 1. And I'm going to create, I try to simulate the one we have discussed in the theoretical background. So 1, 2, 3, 4, and 5. 2, 3, 4, and 5. The vertex 1, we have to set the neighbor, add neighbor, vertex 2, for example. Then the vertex 1, I add another neighbor, a right child, for example, the vertex 4. And then I'm add a neighbor vertex 3 or vertex 4 just to be able to check whether it's working fine or not. Then the vertex 4 dot add neighbors vertex 5. And then the vertex 2 dot add neighbor the vertex 3. And of course we start our algorithm, so breadth-first search BFS, with the root. Not the root for the root, but the root is the vertex 1, for example. So if I run this algorithm, it is going to print that, oh yeah, this is the something like the hash code. Of course I have to override the toString method to be able to get some data that's human readable. So I'm going to return this data, and of course we have to return a string, so something like this. Okay, I run it again. 1, 2, 4, 3, 5. So this is how breadth-first search works. It goes layer by layer. Unlike depth-first search goes as deep as it can, recursively. Here, breadth-first search goes from layer to layer. So we just iterate through the neighbor lists, and we print out everything we find. This for loop. We get the actual vertex, we get the neighbors of this vertex, and if we haven't visited it already, we add it to the queue and visited it. Okay, so that's all about breadth-first search. Thanks for watching.